All right. So we said it was linear if it had a constant rate of change. All right, y'all haven't told me how we find the constant rate of change because we don't remember. Remember, it was the change in y over
X.
the change in x. Okay, so the constant rate of change, we have another word for it today, and that's called our slope. Okay, your slope and your constant rate of change are the exact same thing. We're just going to see it a little bit differently. We are still finding our slope by doing the change in y over the change in x. Okay, but something else we're going to find a way to do it when we have a graph like this is it's called rise over run. Now, if you think about our graph, I have vertical directions and I have horizontal directions, right? So if I had rise, do you think that's going to go vertically or horizontally? Think about when the sun rises, is it going horizontal? It goes up. So vertically, right? Okay, so I can either go up or down. Yes, I know it's the opposite, but if our slope was negative, would the rise be going down? Okay, so run, can I run left and right? Yes. So that is my horizontal. Because isn't y going vertically? Right? My vertical axis. And x, so y and x. It'll make more sense once I show you how to use it, okay? All right. So it says determine the slope of the line. So I need to know what happens to y. How do you think I can do that with this picture?
It rises.
Okay, ignore this for a second. Let's just think of it. I'm having to figure out the change in y over the change in x. There are 2 points here. Do you think I probably need to use those? Yes. Okay. Because in order to know how y changes, I need to know what y is, right? Okay. So we make a little t-chart. What direction do you read? If I'm reading a sentence, what direction do I read? Left to right. So that still applies to how we read a graph, okay? So if I start here, because this is left, and I read to my right, which point comes first? The one on the bottom or the one up top? On the bottom, because if I start here and I go over, this is the line that I hit first. Okay, so I start with this point. What are the coordinates for that point? -1. Try again. -1. -2. So I do -1, -2. Okay. So then my second point, because if you look at this line, is there any other spot where it hits exactly?
No.
No. All right. So if it did, we could use it, but it doesn't. Somebody said, well, 0, 0. Is it exactly at 0, 0 there?
No.
No. All right. So what is my second point?
Positive 1.
Okay. I go over 1. Remember, I go over first. So 1. How much does it go up?
4.
1, 2, 3. Now, the last class on their homework, that was what was causing them some issues, is it was hard to count because they weren't paying attention. They were going really fast, okay? So what I'm going to tell you right now is be careful with your counting. Make sure you count with your pencil. Don't just look at it and be like, all right, that's 4, because a lot of you said 4. But if I really am careful, it's 1, 2, 3. Okay, so I have to figure out, how is my y changing? How do I get from -2 to 3?
+1. I mean, no.
Let's think about this on a number line. Okay, so I have 0. This is -2. This is -1. 1, 2, 3. How many times did I have to go over? 5. So this is +5. Okay. So then how do I get from -1 to 1? Yeah, +2. So my change in y was what? Was 5. What's my change in x? 2. So my slope is just y over x. So it's 5 over 2. And we keep it that way. You know why? Okay, because if it gave me my slope and then it told me to graph, if this is my rise, So I could start here. So if I rise, that means I'm going up. So 1, 2, 3, 4, 5, and my run was 2. I'd go over 2. 1, 2. Did I land on my next point? Yes.
Yeah.
Okay. So this is always rise over run, and that is why we keep it in fraction form. Because with a decimal, would you know what to do? No. Okay, and next year, you are doing this again, but with a calculator, and you will always, if it gives you a decimal answer, you will always turn it back to a fraction. Okay? All right, so here it says the points given in each table lie on a line. Determine the slope of the line and then graph it. So it wants us to determine the slope. It wants us to graph. Now, if you notice, this is counting by 2s, right?
Yeah.
We're not doing that. We're counting by 1s. We're changing how it counts. It counted by 2s. We're just going to count the lines as 1. Just because it gets a little sloppy the other way. Okay. So remember, I have to do my change in y over my change in x. So what is happening to my y? This needs to be a -9. All right, what happened to get from 3 to 1? Look up here. I'm getting smaller, which means I'm doing what? Am I subtracting or adding if my number gets smaller? Subtracting. So I'm subtracting. I go 1, 2, 3, 4. Or no, wait. 1, 2, 3, 4. Okay, so I subtracted 4. That doesn't seem right, does it? Yes. Yes, yes, yes. Okay. How did I get from -1 to 5? -4. Remember, if it's a negative, I would have to take away. I'm still taking away because the -5 minus 4 would give me a -9. If I did 3, all right, -1 minus 3, that gives me -4. All right. So here, how do I get from a -1 to +2?
Plus 3.
Plus 3. Did that work from 2 to 5?
Yes.
That worked from 5 to 8? Okay. So my slope would be what?
Negative, positive, plus 3.
What?
-4, and then 3.
3. That's going to be a big thing too, is y'all have to remember y goes on top. Okay? Now, if I have a slope, I can graph it 2 ways. All right? Well, I have points. That's going to be my easiest way, right? So I have -1 and 3. So I go to -1 and I go to a +3. Okay? I have I have a +2, -1, and then 5. Nope, this should have gone there. Wait a second. 2, -1. Yes. Did I do something wrong? Yes, I did. I did a negative and a negative. Good grief. This should have been -1, 3. I graphed it wrong. 2, 1, and then 5, -5. So those big points are it. Now, you know how I realized that was wrong?
Nope.
Is because I went here, then I went here, but then my next point was down here. If I had a slope and had a constant, it's linear, which means it has to form a what? A line. And somebody was doing their homework and they were like, I know it has a constant, but my line is not right. And I was like, that tells you graphed something wrong. Okay, so that is a good way to check yourself. Now, I'm going to start my first point that I graphed, which is this. So -4, which means my rise would go what? If it's a negative. Up here, my rise went what? Up. So if it's a negative, my rise would go down. So I go down 4. 1, 2, 3, 4. And then it's a +3, so I go over 3. 1, 2, 3. Did I land on my point?
Yeah.
Yes. Let's try it again. -4, so I go down 4. 1, 2, 3, 4. And then over 3. 1, 2, 3. Did I land at my point?
Yes.
Yes. Okay, questions so far? Okay, so here, I don't have any graphing. I don't have a picture. All it gives me is 2 points. All right, so I can set up my T-chart. for every single one of these. Okay, so remember, when I have a coordinate pair, I have x and y. X and y. So if I'm filling out this table, my first point is -2, -4. Okay, my second one is 2, 4. I have to figure out the change in y over the change in x. How do I get from -4 to 4?
Plus 4.
No?
Plus 8.
Plus 8. Think about this, guys. I went from -4. I have to add 4 just to get to 0, right? Then I have to add 4 more to get 4. So that would give me plus 8. All right? So -2 to 2. Well, how many times do I have to go just to get to a 0? And then I go how many more? So that's what?
4.
Plus 4. Okay, so it's my change in y over x. So how would I write that? 8 over 4. Can that be reduced to what? 2. So my slope is 2. If it wanted to rise over run, what do you think you would do with 2? How could you make 2 a fraction? 2 over 1. All right, my first point. My second point. All right, how do I get from 0 to -2? -2. How do I get from 2 to 0? -2. So if I write that, -2 over -2, what is that? Why is it a positive and not a negative?
Because 2 positive equals a positive. I mean, 2 negative equals a positive.
2 negatives equal a positive. Okay. My first point, so I have 3, 4. And then my second one, 4, -2. How do I get from 3 to 4? Plus 1. Okay. How do I get from 4 to -2? Okay, so which one goes on top?
-6.
Over positive 1. Okay, what does that reduce to?
6.
Yeah, just -6. Why is it negative?
Because a positive and a negative equals.
Yeah, remember, guys, multiplying and dividing. When my signs are the same, it's a positive. When they're different, it's a negative, right? They're different, so it makes it a negative. Okay, so this one says determine the slope of a mountain. Now, it gives me a picture here. Do y'all agree this is the slope?
Yes.
Yeah. All right, so how would I know which one is x and y? Any thoughts? Okay. Rise over run. Which one would be my rise? 100. That's going vertically, right? Which one would be my run? So if I put rise over my run, do I have a slope? Yes, but can it be smaller than that? Okay, how can I simplify that? Remember our zeros trick? Do they both have a 0? Okay, so I can take one away. Do they both still have a 0? Okay, so I can take another one away. Do they both still have a 0? No, so that's as small as I can go. That's my slope. Not too bad. This is one of those things, the more you do it, the easier it gets. Okay, you've just got to drill in your head y over x, rise over run. Okay. All right, so this is a star question. Now, the people who write and make the star test, they're kind of mean, right?
Very.
Okay. So, they are being tricky on this one. Because I have to do the change in y over the change in x. Yes? Okay, I just want you to look at this graph for a minute and somebody tell me something that they noticed that makes it tricky.
That it goes down the more it gets, or the more bottles, the less it costs. Or how you.
It's missing a number? What do you mean? It's missing 3. So I go from 1 to 2. So I added 1. But then
And then
here,
out of 6,
I added
that's
2, added 2, added 2.
And then
Okay, so here is minus 5, but then it's minus 10, minus 10, minus 10. Okay, so somebody was like, well, that means there's not a constant. It's not right. That's not necessarily true, and I'm going to show you why. Okay, because let's say if I did negative 5 over 1, if I looked at that one and didn't go further, that's my slope. Okay, but then it's like, no, well, here's negative 10 over 2. Are those equal to each other? Yeah, because if I reduced this by 2, what would it give me? Negative 5 over 1. Okay, now, if I wanted to go in and fill in that gap, so if I wanted to count by ones, 1, 2, 3, 4, 5, 6, 7, 8, if I did 60 minus 5, that gives me what? 55. If I did minus 5 again, did that give me what it had? Did it give me 50? 55 minus 5 is 50? Okay. Is 50 minus 5 is 45. 45 minus 5, is that 40? Okay. 45 minus 5 would be 35. 35 minus 5 is 30. So you see, all it did was skip a number, but did the constant change? No, because it reduced back to negative 5 over 1. But a lot of people immediately said there is not a constant. Now look, you see right here, this is going from 1 to 2, right? Well, and then it goes to 4, then it goes to 6, then it goes to 8. If I filled this in, so I did 3 is 55. Well, here's 3. 55 would be here. Okay, 5 was 45. So 5, here's 45. Okay, 7 was 35. Did that make my line straight still? Does it look more constant that way? Yes. All right, so is it still linear? So what is my slope? But if this is what it gives me, how would I write that as my answer? What is negative 5 over 1? Negative 5. What is negative 10 divided by 2? Negative 5. So that's all I have to put. So was it hard to find that? No. But what did it try to do? It tried to trick you and make it think there's not a constant. Okay?
On the star test, if you like write your number at the top, but you forget to bubble it in, will they count it wrong?
Yes.
I think so.